Alright, this is for Algebra 2, section 6.2, and it's entitled Polynomial Functions. And what I'll try to do is I'll try and do a few problems from your homework and kind of cover some note topics as we go through. So problem number 4 on your homework was simply to write the polynomial in standard form, or the polynomial expression in standard form. Okay, and so for a problem like this, all we have to do is carry out exactly what it says. It says take x plus 2 times x plus 2. Now you do have a choice here of what you multiply first. I think in this case you could distribute the x to the first x plus 2, but these are so easy to FOIL together, or distribute and multiply together. I think I'd use it. Now remember, we do call it FOIL, but it is distributing. So we distribute that x and we get x squared plus 2x. We distribute the 2 and we get 2x plus 4. And so we end up with x times combining our two 2x's in the middle, which will give us 4x's, and then distributing this final x to everybody gives us our polynomial in standard form. So that's all you had to do with the first few problems. Nothing really new in those. Alright, let's jump to the next group, which is 7 through 12. I'm going to do number 12 because 12 is probably the hardest one. And what they're asking here for is to factor the polynomials. We've talked about steps to factoring. We haven't talked about cubics really specifically, but nothing really has changed. We always first start by looking for a GCF. Now this is not an equation, it's just an expression, so we can't divide anything away. We have to keep track of things and just pull them out. In this case, every term has at least an x in it. That was an 18x up here. And every term has an x in it, so we're going to factor that x out. Okay, now just because you've taken out a GCF doesn't mean you're done, because we still have a quadratic and it's a trinomial, and those, if they aren't prime, do factor as a product of two binomials. So to get the x squared, it has to be x times x, and to get the 18 over here can either be a 1 and 18 or a 2 and 9. Well, we're looking for this middle term to be 7x, so we want whatever numbers we choose, or pair of numbers we choose, to have a difference or a sum of 7. 1 and 18 don't add to 7, don't subtract, or have a difference of 7. 2 and 9 don't add to 7, but they do have a difference of 7, so we'll put 2 and 9 here. We want them to have a difference of negative 7, so we want this to be negative 9, which gives us negative 9x on the outside, and positive 2, which gives us plus 2x on the inside, and those have a difference of negative 7x. So there is the complete factorization. X times x plus 2 times x minus 9. In general, you know you have completely factored it when each factor is now a linear factor. They only have x's to the first power in them. Kind of covers the second group. 15, I'm going to leave that one for you guys to think about and work on your own. 17 through 35, we had to do the odd ones, and here we had to find some zeros. But those aren't too hard. They even suggest you use your calculator. I'm not sure why you would. So get 17 really quick. Remember, zeros are just asking you what's the x value that can be put into the function. Remember, the function is the formula that give you 0 out. So what can I plug in for x to get a 0 on the outside? And because it is already factored, really I just have to find out what makes the first factor equal 0, because then the product is 0. Or what could make the second factor equal 0. And so I get two answers. X is either 2 or x is negative 9. And it's great when they're already factored, because then finding zeros is very simple. 19 is easy, or very similar to that one, I should say. Now, starting with 21 through 27 in that group, they're actually using or want you to apply a theorem. It's kind of a theorem that makes sense. It's called the Factor Theorem. And the Factor Theorem basically says, let me write down problem 21's information first. It says that these things right here are zeros. And the Factor Theorem says a number can only be a zero of a function if x minus that number is a factor. So we're kind of working the problems in reverse to the previous problems we did. We're saying, usually what we do is we say, hey, here's how it factors, find the zeros. Now we're going in the opposite direction and saying, well, here are the zeros, so let's write the factors. And so it's always x minus the zeros. Okay? Now we don't want to leave it in factored form because they want the polynomial in standard form, so what we have to do now is we have to multiply these together. So I would do the first pair of binomials, and I'm going to do those kind of quickly, but again distributing everybody. We get x squared minus 11x plus 30. And then we have to take that times this third binomial, x minus 7. Again, this is distributing, so we distribute x squared to everybody, x cubed minus 7x squared. We distribute negative 11x to both, negative 11x squared plus 77x. And finally we distribute 30 to both, and that gives us 30x's minus 210. And that still all equals 0, and now we collect any like terms that we have. We got an x cubed. There's a couple of x squared terms. I hope that's right. That'd be, yeah, I think that's right. That's negative 18x squareds. Right here we have a x term and another x term, so that looks like 117. 107 rather. 107 x's, and then finally our constant minus 210. So there's the polynomial, and it has those zeros and those factors right there. So if you have the zeros, then you have the factors. 29 through 35, that's kind of our next group. And again, not too difficult. They say find the zeros for these things, and they say state multiplicity. And what multiplicity means is it means you have repeats in zeros. So if we want the zeros for this function, again remember it's asking us what x values give you a y value of 0. By writing it with that exponent, they've actually told us that it factors as x plus 3, x plus 3, x plus 3 equals 0. Each factor gives you a solution. Now I'm not going to solve each one because they all give you the same solution. In this case we get negative 3 and it happens 3 times. So we say our solution is negative 3. We use brackets for solution sets. And we say it has a multiplicity, erase that a little bit, multiplicity of, hope I got it all, of 3. And that 3 has nothing to do with this 3 here. That 3 has to do with the fact that it happened 1, 2, 3 times. Okay, if it only happened twice, we'd say it had a multiplicity of 2. It happened 5 times, multiplicity of 5. So when you're stating multiplicity, what you're looking for is repeated factors because they lead to repeated solutions, and those are what we call multiplicities. So here again is your homework, page 311, 4 through 6, 7 through 12, 15, 17 through 35, odd. And you had a challenge problem that's due on Friday. You're going to turn those in with Monday's challenge problems, and that is number 62 on this same page. Hopefully that will help you complete the assignment.